Hello everyone. In today's video, we'll understand the event loop of JavaScript. This is how JavaScript decides what code runs and when code runs. So let's get started. First, the problem. JavaScript can only do one thing at a time. It runs your code one line after another line. But something feels off. A timer can wait quietly in the background. A network request can wait too. Your web page still feels smooth the whole time. The question is, how can one thing at a time code do all this without freezing? Here's the answer. The answer is a system which is called the event loop. It works quietly behind the scenes. It decides the real order your code runs in. Now, let's break down this problem into small and simple pieces. Then you will understand and see how it exactly works. The call stack. JavaScript runs your code inside something called the call stack. Think of it like a stack of plates. Every time a function runs, it gets added to the top. When that function finishes, it comes off the top, one at a time. Only the plate on the top can do any work. JavaScript will not touch the next plate until the top one is done. This is what one thing at a time really means. But what happens when something takes a long time, like a timer or request to a server? Let's say this. Web APIs handle the slow stuff. JavaScript doesn't wait around for slow tasks. It handles them up to the browser instead. The browser has its own helpers, and that's called web APIs. How it works? You call something like setTimeout or fetch. JavaScript sends the task straight to web APIs. The web API works on it quietly, outside the call stack. Your code keeps running the whole time. Once that background work is done, it has to go somewhere, right? It cannot just jump back to your code right away. Let's see where it goes. The callback queue. When a web API finishes its job, it does not run instantly. It gets placed into a line called the callback queue. This queue is also called macro task queue. Every task in this queue waits for its turn. It can only run if the call stack is completely empty. This is true even if the task finished a while ago. There is one more queue, and this one is allowed to skip the line. Let's see this. This is called the micro task queue. Promises do not go into the regular callback queue. They go into the faster line, called the micro task queue. Micro tasks always go first. Every micro task runs before any macro task. This happens very single time, with no expectations. Even a finished timer has to wait for the micro task first. So who is exactly the in charge of all of these lines? That job belongs to the event loop itself. The event loop job. The event loop keeps asking one simple question. Is the call stack empty right now? If the answer is yes, first it runs every micro task, one after another. It keeps going until that queue is completely empty. Then it takes just one from the macro task queue. Then it checks the call stack again, then repeats. This repeats forever. This loop never really stops. It keeps checking, running all micro tasks, then one macro task, again and again forever. That is why it is called the event loop. Now let's walk through a real code, one line at a time. Seeing the real order will make this much easier to understand. Reading the order for real. Picture 3 lines, a normal console log, a set timeout, and a promise. What actually happens? The console log runs first. It is normal code, so it runs right away. The set timeout gets handed to a web API. Its callback waits in the macro task queue. The promises dot then goes into the micro task queue instead. It waits in the faster line. The real output order. The normal console.log prints first. The promises code prints second. Microtask always go before macrotask. The set timeout code prints last, even if the delay was 0 milliseconds. Why this matters? This is why timing bugs happen. Code doesn't always run in the same order that it is written. Once you understand the event loop, the order finally makes sense. So that's it for today. If you like this video, leave a comment and hit the subscribe button. See you in the next one.